So we're going to do section 4 today. This is chapter 6, section 4. We're using inverse functions. So this is, again, this may be a repeat topic, but probably not something you spent a whole lot of time on in Algebra 1. So we're going to go through this. It's really not that difficult of a section. There's a few things about it that can be difficult, and we'll talk more about that really when you get into class and start doing the work. There are a few things that you could get confused on, but those are going to be specific problems. For the most part, it's a pretty straightforward topic. So let's go ahead and get started. Our vocabulary for this section is just simply an inverse relation interchanges the input and output values of the original relation. So now what we mean by input is x values and output values are y values. If both the original relation and the inverse relation happen to be functions, we call them inverse functions. So they're pretty much the same thing. It's just that we can't call it an inverse function if it's not a function. So reading through this, it says the graph of an inverse relation is a reflection of the graph of the original relation. So basically what you'd look at is if we have inverse functions, if you take a graph, and I'm going to draw a real small graph here, and we should all know what the graph y equals x looks like. It's a straight line that goes through the origin like this. What's going to happen is whatever graph is up here, it will reflect completely over this line. Now obviously we could have pretty much anything here, but any graph that you have would be a perfect reflection over this line if they are inverses of each other. And we'll kind of see that as you do a couple of problems and you use the graphs and you put them in a graphing calculator. Like I said, we're not going to deal with that a whole lot with what we're doing today, but we're going to deal more with the equations. So, all right, so let's go ahead and get started here. So basically what we're going to do is we are trying to find the inverse relation of y equals 4x plus 2. So when you're trying to find an inverse, your first step, step 1, is switch your variables. So what does that mean? It means that instead of 4x plus 2 and instead of y equals, we're just going to switch them. We're going to put x equals 4y plus 2. Step 2, is going to be to simply solve for y. And so we're going to go through and solve for y just like we would with anything. Minus 2, minus 2. So we're left with x minus 2 equals 4y. Divide by 4. Divide by 4. Now the one thing I am going to want to see you do on this is let's not leave it like this. Let's turn each of these into a fraction. So this will end up being y equals x over 4 minus 2 over 4. And then don't forget to reduce. Y equals x over 4 minus 1/2. So that is our inverse relation. So it's real simple. It doesn't matter what equation you have. All you're doing is switching your x and y values and then solving for your y. That's how you find an inverse relation. So now when we're talking about functions, what we're going to do is we have just found out that that 1/4 x minus 1/2 is the inverse relation. So we're dealing with functions here, but basically what we're doing is we can find whether two functions that we have, whether they're actually inverses of each other. So we know that these are inverse relations of each other because we just did it. So here, let's read this. It says functions f and g are inverses of each other provided f of g of x. Remember, we just finished composite functions in the last section. F of g of x will equal x, literally, like that's what you will end up with. And your g of f of x, so you reverse it, you'll get x again. So basically when you take the composite functions of each other, you should get a result of x on both of them if they are inverse functions. So now one thing we want to notice is right here they're saying, okay, verify that f of x and f in this -1. So that's read f inverse. But what this means is we just want to, we're going to say that's the same thing as g. because we can interchange that. It doesn't matter. We just want to be able to match it up with what's up here. So what we're going to do is we're going to take our two functions here and we're going to do our composite. So it looks like this. F of g of x is going to look like 4, and then in parentheses will be 1/4 x minus 1/2, and then we have plus 2. So we multiply through. 4 times 1/4 is 1, so 1x. 4 times negative 1/2 is 4/2. So we multiplied this, and then we multiplied this, and we get 4/2, which is just minus 2. And then we have our plus 2 here at the end. The minus 2 and plus 2 cancel out, so we're left with x, which is what we were looking for. Now we're going to do g of f of x. And this will be, we're going to start with our g of x, so that's going to be 1/4. And then in parentheses, instead of x, we will put our other function, which is 4x plus 2. And then we have our minus 1/2 at the end. So again, we're just going to distribute through this. 1/4 times 4 is x. 1/4 times 2 is 2/4, which is going to be 1/2, so plus 1/2, minus 1/2, and of course these cancel out and we're left with x again. So what that means is, it means that these two functions are inverses of each other. Now we already knew that because we did it above in this problem up here. We found what the inverse relation was already. But in any instance where you're given two functions and you're being asked if they're inverses of each other, what you can do is you can either find the inverse of this by hand, or you can just simply do your composite functions and make sure both of them equal x. A time that you'd want to do something like this more often is when it's very difficult for you to find the inverse by just switching the variables. So it might be dealing with things that have squareds in them or cubes in them, where it's a little bit harder to switch the variables and solve. So you would write that f and g are inverses, and then we're done. Okay, so let's go ahead and move on to the back page. Again, this is a pretty quick section. This shouldn't take us the full 15 minutes. Okay, we're going to look at this story problem. And again, this story problem isn't that difficult because they're giving us a function already. So it says a small company produces greeting cards. The cost C in dollars of producing N greeting cards per month can be modeled by this function. So the first part is they want us to find the inverse of the model. So we're simply going to use our function. So we have C equals 360 plus 0.60n. So if we want to find the inverse, we have to switch our variables. So it'll be n equals 360 plus 0.60 and then c. And now we're going to solve for c. Minus 360 on both sides. So we're left with n minus 360 equals 0.60c. So we're going to divide both sides by 0.60. And what we're left with is, again, we're going to divide each of these by 0.60. Well, if you divide this by 0.60, you get a pretty weird decimal. But what's going to happen is I'm going to change that to a fraction. So this is like saying 0.60 is like 3/5. So if 0.60 is 3/5, then when I divide by 3/5, I'm going to get 5/3. So we will end up with 5/3 n. And then we do negative 360 divided by 0.60, and we get 600. So it's minus 600 equals C. So this is part A. Okay, we're done. That's our inverse. Now the second part says use the inverse function. So it wants us to use our new function to find the number of greeting cards produced in a month in which the company's total cost was $6.15. So we would just put $6.15 in for C. So it'd be 615, and then that's going to be equal to 5/3 n minus 600. And we just go through and solve this problem like we normally would. Add 600, add 600. So we're left with 5/3 n equals 1,215. Fix that. Okay, so then we divide by 5/3. Divide by 5/3. And you can use a calculator to do that if you want, and you will get n equals 729 greeting cards. Should always label a story problem with whatever your answer is. So 729 greeting cards. Okay, so that is basically how you're doing inverses. There's really not much to it. Okay, I will go over a couple of other things in a second here. I'm going to go back to one of the problems we did. But first, let's talk about the horizontal line test concept. So when we dealt with regular functions, if this right here, both of these are f. Okay, so this is our f. And this is our f right here. So these are not inverses, these are just our f. Normally, what we would have done is if I wanted to find out if f was a function, we would do what we call the the vertical line test. In other words, you would draw, and I'm going to do a different color here. So you would draw vertical lines through your function. And what you'd be doing is you're trying to see if that vertical line, each individual vertical line, if it ever goes through more than one point on the graph. And if it doesn't, then we have a function. If it does, then we don't have a function. Well, now when we're dealing with inverses, here's our f. Here, let me change the color. Here's our f. And what we're doing is now we're doing a horizontal line test. So the horizontal line test means that we're actually checking to see if the inverse would be a function. So this is still a graph of our regular function. Now that we do a horizontal line test, if the horizontal line test will ever go through more than one point, then that would mean that the inverse is not a function. So you see on this one, it doesn't matter how many horizontal lines we draw, it'll never go through more than one point. So therefore, we know that the inverse will be a function. We also would figure out that the regular function is a function because the vertical line test passes. On this one, however, right away you can see that our horizontal line goes through more than one point. It goes through here and here. Therefore, our inverse would not be a function. However, our original function still is a function. So what it kind of shows you is that whether you have a function or not, the inverse still may not be a function. So that's just something that we're going to be dealing with. Okay, so the last thing that I want to talk about, and I guess we are approaching 15 minutes, but this stuff still goes by pretty quickly, is we are going to be dealing with domains and with domains again, and we talked about this in the last section. So when we deal with domains, basically here's what you need to remember. The domains are figured out the same way, but here's the deal. If I ever do a problem, in this case it doesn't really matter because the functions are so basic, but whenever you find an inverse, if you find the domain is limited, say all of your negative numbers don't work, what has to happen is when we're dealing with our inverse function, we have to go back to our original function and it's got to apply for both. Okay, so if we're dealing with inverse functions and we found out that this function, no negatives work, then we have to go back and we have to apply the domain to this as well, whether it's true or not. Okay, so an example of that would be x squared and square root of x. So the inverse of x squared is going to be the square root of x. So you need to apply those domains appropriately for both of them. So we'll deal with that with specific problems, but it shouldn't be that big of a deal, so I'm not going to go into a lot of detail about it here. So, okay, so hopefully this makes sense. Hopefully this is an easier section for us and we can move forward with it. But if there's anything that you have questions on this video, make sure you take note of it and you bring those questions tomorrow.